Hello all, welcome to Teacher at Home. Today class we are going to learn the 10th chapter, that is the blanket of the earth. The given lines is the translator version of the pledge you have taken as part of the World Environment Day. Have you ever thought of the logic in planting trees as part of the conservation of environment? As you know, an atmosphere is a blanket of air surrounding the earth. It is the atmospheric gases such as oxygen, carbon dioxide which play a major role in maintaining the earth as a life-protecting planet. Plants are significant in regulating the amount of the gases in the atmosphere. It is through the process of photosynthesis that plants gather energy for their growth. In the process, plants intake carbon dioxide and give out oxygen. Now you might have understood the role played by the plants in maintaining the balance of life, supporting the gases in required proportion. Let us see in the constituent of the atmosphere other than the gases such as oxygen, carbon dioxide and also their significance. Atmospheric composition. Gases, moisture and dust particles are the major constituents of our atmosphere, the blanket of Earth. It is the gravitational attraction of the Earth that holds the atmosphere close to the Earth. Atmospheric gases. Familiarize the major gases in the atmosphere and their proportionate volume by observing the given table. Gases and volume. Nitrogen 78.08, oxygen 20.95, argon 0.93, 0.93, carbon dioxide 0.037, ozone 0.01, neon 0.002, helium 0.0005, krypton 0.0001, hydrogen 0.405, xenon 0.409. Almost all gases in our atmosphere support the sustenance of life directly or indirectly. Observe the picture given. You can notice the importance of gases such as oxygen, carbon dioxide and nitrogen in the existence of life forms. Plants make use of carbon dioxide for photosynthesis. Man and other organisms make use of the oxygen for respiration. Plants make use of nitrogen for their growth through nitrogen fixation. Water in the atmosphere. Water molecules are a major constituent in the lower parts of the atmosphere. As you know, water reaches the atmosphere through evaporation and causes cloud formation and rain. There is spatial and temporal variation in the amount of water present in the atmosphere. Look at the factors influencing the amount of water in the atmosphere. Rate of evaporation will be high at places experiencing high temperature. So the water content in such places will be high. Amount of water will be high in the atmosphere, close to the surface water sources such as ocean, rivers and other water bodies. Dust particle. Other than gases and water content, dust particles also form part of the atmosphere. Look at the main sources of dust particle to the atmosphere. Dust particles brought to the atmosphere by wind. Dust particle erupted through volcanoes, ash formed by burning of materials. You have learned that there is frequent condensation concentrating around the fine dust particles in the atmosphere. As the fine dust particles in the atmosphere help in cloud formation, they are called as condensation nuclei. The presence of atmosphere extends to about 10,000 kilometers from the Earth's surface. But it is estimated that about 97% of the atmospheric air remains within 29 kilometers from the surface. The gases get rarefied with increasing altitude. Atmosphere as a greenhouse. Do you know why gas is largely used in the construction of buildings in cold countries? Glass is largely used. Glass planes have the capacity to allow insulation to pass through them and check the terrestrial radiation. As temperature is maintained within the buildings without fall. You can perceive from the given figure how this property of glass is made use in the agriculture sector in cold countries. By preventing the terrestrial radiations, the temperature required for the plant is retained. Greenhouse gases retain the surface temperature of the earth by absorbing the terrestrial radiation. Inside such construction, such buildings are called as greenhouse. Some of the gases present in the atmosphere also can also permit insulation and prevents terrestrial radiation. Gases such as carbon dioxide, methane, ozone, etc., and the water vapor present in the atmosphere absorb the terrestrial radiation and retain the temperature of the atmosphere. This phenomenon is called greenhouse effect, and the gases causing the phenomena are called greenhouse gases. Even if greenhouse effect is essential for the existence of life, the uncontrolled increase in the greenhouse gases causes rise in the temperature of the atmosphere. Greenhouse gases are reaching the atmosphere mostly through some human interventions. Do you know the sources of greenhouse gases? Greenhouse gases enter the atmosphere through natural means such as volcanic eruptions, decay of biological matter, as well as through human activities such as deforestation, burning of fossil fuels, etc. Some activities leading to a large-scale emission of greenhouse gases are shown in the figure. Carbon dioxide is dominant among the gases released in this manner. Changing atmospheric condition. Metric ton, 1 metric ton is equal to 1000 kg. Industrialization, urbanization, etc. lead to rapid changes in the atmosphere. It is estimated that 6000 metric ton carbon dioxide is getting added to the atmosphere every year in this manner. Studies reveal that there is a rise of 0.4 degrees in the average atmospheric temperature during the uncontrolled increase of greenhouse gases in the 20th century. This increase in temperature in the atmosphere due to the greenhouse gas is referred to as the global warming. Let us see how global warming becoming a threat to life forms of the earth. Sea level may rise as a result of melting of polar ice. Destructions in the coastal ecosystem may lead to the problems such as food crisis, large-scale migration, etc. Global warming lead to a depletion of many species of plants and animals in the ecosystem. Kyoto Protocol. Among the global efforts to control greenhouse gases, Kyoto Protocol is the most important. The Kyoto Protocol, proclaimed as part of the Kyoto Summit in Japan in 1997, came into effect with the concurrence of 141 countries in 2005. As per this 35 industrial countries were warned to reduce 5% of the greenhouse gas emission by 2012, then the same in 1990. You might have understood that it is the increase in the amount of greenhouse gases which lead to global warming. Do you think we can completely avoid such activities? Conduct a poster exhibition in the subject global warming and remedial measures as part of the World Environment Day on behalf of the Social Science Club. Ozone as an umbrella for the earth. As the ozone gas is concentrated in the upper atmosphere as a layer, it is called ozone layer. It protects the life forms of the earth by absorbing the harmful ultraviolet rays from the sun. Ozone formation. At an altitude about 20 to 50 km in the atmosphere, the ultraviolet rays from the sun splits up into ordinary oxygen molecules to single atom oxygen molecules. These single atom oxygen molecules react with ordinary oxygen molecule to form a triatomic ozone gas. The process is called ozonization. Chemical reaction is shown. Ozone formation. Step 1. Oxygen molecule ultraviolet rays split into oxygen. This split oxygen it combines with the diatomic molecules to form a triple ozone molecule. Ozonization process 3O2 sunlight 2O3. Climate change, skin cancer, blindness, premature aging, stunted growth of plants, crop failure, destruction in food chain. It is negative impacts of ultraviolet rays. Refrigerators, air conditioners, different type of sprays, fire extinguishers, paints, etc. are sources of gases such as chlorofluorocarbons, etc. Such gases could remain unaltered in the atmosphere for a long time. These gases rising to the upper atmosphere react with ultraviolet rays from the sun to form the chlorine and bromine. It is estimated that each chlorine atom is capable to decay about 1 lakh of ozone molecules. Bromine is 40 times more reactive than chlorine. So it is more reactive than chlorine. This depletion in the atmospheric ozone layer it is known as what? Ozone hole. Montreal Protocol. The Montreal Protocol is an international treaty aimed at banning the products that causes ozone depletion at various levels. It was signed as a landmark for the conservation of ozone in 1987 Vienna Summit. It has been proved that By the implementation of the treaty, that ozone depletion over the Antarctic region has considerably lowered. To protect the ozone layer, to create awareness on the need of conservation of ozone and to control the use of products leading to ozone depletion, 16 September of every year is observed as World Ozone Day. You might have understood the characteristic and significance of each of the constituents in the atmosphere. Just like the composition, the structure of the atmosphere also is critically influencing the life forms on the earth. Structure of atmosphere. The composition of the atmosphere is somewhat uniform up to about 90 kilometers from the surface of the earth. This part of the atmosphere it is known as homosphere. Beyond this, there is no uniformity in the gaseous composition. So, the part of the atmosphere beyond 90 kilometers from the earth, it is called heterosphere. Based on the temperature, different levels, atmosphere can be divided into different layers. From the given diagram, you can read the change in temperature with altitude and can identify the layers on the atmosphere. Each layer in the atmosphere has its own indigenous characteristics. Let us see the characteristics of atmospheric layers as well as the significance on us. Troposphere. This layer extends up about 90 km from the surface of the earth and lies close to the earth. The height of the troposphere is more in the equatorial region because of strong convection here, about 18 km. Almost all the weather and climatic phenomena such as cloud formation, all the weather and climatic phenomena such as cold formation, rain, snow, wind, thunder and lightning etc. take place in this layer. In the troposphere, the temperature decreases at a uniform rate of 1 degree Celsius for every 165 meters of altitude. It is called normal lapse rate. Transition zones. Transition zones are the parts of the atmosphere separating the major atmospheric layers. Tropopause, stratopause, mesopause and the respective transition zones between troposphere, stratosphere, mesosphere and thermosphere. The ozone zone of transition above the troposphere is called tropopause. Stratosphere, next coming is stratosphere, extends up to a height of about 50 km from the earth and lies above the tropopause. In the lower parts of the stratosphere, there is no change in temperature with altitude. This zone is called what? Isothermal zone. Beyond this, there is increase in temperature with altitude. Ozone layer, which forms part of this layer, absorbs the harmful ultraviolet rays from the sun and prevents it from reaching the earth. Allows the free movement of jet aircrafts through clear atmospheric conditions and absence of air gutters. The zone of transition above the stratosphere is called stratopause. Mesosphere extends from about 50 to 80 km altitude from the earth. Temperature decreases with altitude and the lowest temperature is felt at the mesopause, that is minus 80 degrees Celsius to minus 100 degrees Celsius. The meteors on reaching the mesosphere gets burned out due to friction. The zone of transition above the mesosphere it is called mesopause. Thermosphere extends from about 80 to 600 km altitude. There is considerably increase in temperature with altitude. The lower part of the thermosphere is known as the ionosphere. Ionosphere helps in the transmission of radio waves. Then next is the unique composition and structure of Earth's atmosphere has critical influence of the substances of life on Earth. So for retaining a life supporting world for the future generations, we must attain the fragile balance on the atmosphere. Let us follow a lifestyle in support of this. Atmosphere is a blanket of the earth. It is my duty to conserve it. Atmosphere. Composition of the atmosphere. Greenhouse effect. Structure of the atmosphere. Gases, dust particles, water content, global warming. Greenhouse is global warming. Structure of the atmosphere, that is troposphere, stratosphere, mesosphere and thermosphere. Then coming it is the summary. Gases, dust particles and water content are the major constituents of the atmosphere. The existence of life is influenced by each of the atmospheric constituents. The surface temperature of the Earth, it is retained when the certain gases in the atmosphere prevents terrestrial radiation. Greenhouse gases are formed mainly through human activities. Global warming is caused by greenhouse effect. It is the ozone layer in the atmosphere which protects the biosphere from ultraviolet radiation. The peculiar structure of the atmosphere is based on the temperature condition. Each of the atmospheric layers are very significant for us. So that's all about reading this chapter. Okay, thank you.